Okay, let's say you've got a graph here of y equals sine of x. Now suppose you're asked to find sine of x equals 0.3. So, well, if 0 is here and 1 is here, we're going to guess 0.3 to be around here. So this here would be one solution, this here would be another solution, this here would be another solution, because anything along here is equal to 0.3. 0.3 is here. So this here is a solution, this here would be another solution, and so on. So you could sit here and list all the solutions, and it would go on forever. A better way of doing it is to do this here. So at the moment you want to solve sine of x equals 0.3. So you would jump to your calculator. So x equals inverse sine of 0.3. So when you jump to your calculator, remember your calculator will give you a principal solution between here. Okay, so it will give you this solution here, but then don't forget we've still got this one here. But we would deal with this one later on. But for the time being, let's just concentrate on this solution here. So when you jump to your calculator, when you punch this into your calculator will give you this principal solution here. Okay. So let's do that on our calculator. Hang on. Jump to your calculator, punch in 0.3 here, and then inverse sine. So this one here. So it gives me a solution of 17 point. Let's round it off to 17.5. Okay. So x here equals 17.5. So this value here is 17.5 degrees. Okay. So when you put when you put 17.5 into this x here, it will give you 0.3. Well, anyway, one solution is 17.5. But the thing is, we've got so many other solutions here. So once you've got your principal solution here, remember, by you punching this into your calculator, it gives you one solution here, in this range here between minus 90 and 90. But don't forget you've got all the others. But here's the thing: once you've got one solution here, you know the period is 360, because it repeats itself every 360 here. So this here is one cycle. This here is another cycle. My point is that once you've got one solution, you can add 360, and then that will give you another solution. Okay, and then you can add another 360. That will give you another solution. But don't forget, later on we still got this one and this one, which we will deal with later on. But once you've got your principal solution here, add multiples of 360. So if you add another 360 here, that would take you to here. But then if you add, let's say, this is 360. 360 times 2 is 700. Well, if you start with your principal solution here and then add 720, it will give you this solution here. So basically, once you've got your principal solution, which is 17.5, you can add multiples of 360. So don't forget, when you add 360, it just gives you these solutions. It hasn't given you this one, which we will deal with later on. Okay, so principal solution here, and then add three multiples of 360. Let's just say 360. The way you would write is x equals your principal solution here, 17.5, plus multiples of 360. So 360n, and then you have to say where n. Hang on, where n. Hang on. So you have to write x equals 17.5 plus 360n, where n belongs to the set of integers. So here I've done a video on this. So remember our number line. Hang on, our number line is like this: 0, 1, 2, 3, and so on. And then you've got your -1, -2, 3 here. Well, all these whole numbers, including the negatives and 1 here, all these numbers here belongs to this z here. Well, this z here is a symbol for all the integers, and all these are the integers here. Negative whole numbers, including negatives and ones. These are all integers. So what we're saying here is that yeah, if you select 360n, if you select any n here belonging to integers here, so you can't select 2.7 somewhere in here, because this here 2.7 does not belong to this z here. Okay, so you've got to select n where n belongs to this set of integers. So this is a symbol for all the integers. Well, my point is that, let's say if you select 1 here, if you select n to be 1 here, then 360 times 1 will be 360. So one solution is 17.5 add 360. If you select, let's say 2 here, and put 2 into the n here, so it will be 17.5 plus 360 times 2, because we're putting 2 into here, so that will be 720. So that is another solution. Even if you select a negative 1 into this n here, so it's like you saying 17.5 and then 360 times negative 1, that would be negative 360. So it's like this, negative 360. So it's like this, you finding out this solution here, and then you go back 360. So that is also, hang on, let me try and illustrate on here. Hang on. So once you've got your solution here, hang on, let me just move this across. So bear with me. So once you've got your principal solution here, remember the principal solution is between negative 90 and 90. Once you've got this solution here, if you remember, our solution is x equals 17.5 plus 360n, where n belongs to a set of integers. So if you put negative 1 into this n here, it's in effect 17.5 take away 360. So that there is another solution, because if you look at this here, principal solution, which is this bit here, and then when you take away 360, it will take you to here, which is another solution. So even if you put a negative number into this n here, it will still give you a solution. Okay, so in the next video, I will show you how you by you using a calculator, it will give you this principal solution here. But then in the next video, I will show you how you can find this solution here, and then after that we can just keep on adding multiples of 360. So that will give us this one here, and then if you add another 360, that will give us this solution here. And then if you take away 360, it will give you this solution here, and so on. So far in this video, we've got our principal solution here, and then we managed to find out this solution, this one here. In the next video, we will find this one here, and then add 360 will give us this one. Add another 360 will give us this one. Once you've got this one here, take away 360 will give us this. Take away another 360 will give us another solution in this direction. Okay?